All right, welcome back to computer science. Let's do a quick big picture overview, recall of what we've been learning yesterday. Identifier names, what was after that? Objects. So I think we studied objects yesterday. They're created by the interpreter. Garbage collection, when they get rid of them. Variables will store objects in memory. This is all within memory. Right, we talked about floating point numbers used for measurements. Talked about scientific notation, the rounding feature. So F quotation mark, curly bracket. F quotation mark, curly bracket. Digit you want after the decimal point to be rounded to, colon, period, curly bracket, quotation mark. So pretty long, but that's all right. What else do we do? Objects, floating point numbers. I think that's generally the big picture of what we were doing. I think. Yeah. Looks right. Name binding. That's the process of attaching a name to an object. Can that be functions, lists, etc., or is that just variables? I think it's everything. Each name can only be one object. Associating names with interpreter objects. Probably pretty general. Properties of an object. ID, that's numerical, basically memory address, value, and type. Type cannot be changed. Variable keeps object stored. More like name probably keeps the object stored in memory. Names themselves are objects. Properties of objects: value, displayed by print, type, identity, ID and type functions, floating point numbers, float, floating point literal, float. What is a float? It's kind of like the int function, yeah. Scientific notation: overflow error if it's too big of a number. Oh no, it's okay. F quotation mark curly bracket, that was right, but then it's essentially the floating point variable, the variable for the floating point, colon, period, hashtag. It was hashtag being the number, place the number, and then F curly bracket quotation mark. Python automatically outputs 15 digits after the decimal point, it looks like, typically. So I'm going to jump back in, and then we'll be back to recall what I learned in a little bit. All right, no new notes today right now for what we learned. I was just doing a lot of practice problems. It looks like when we're printing, anytime you're going to have a float that you manipulate, you're going to want to put F before the quotation mark of the string, so it's a little interesting, but noted. We started on an MSP, just basically taking inputs, putting outputs, print statements, input statements, integer function. Basically, a user inputs a piece of an integer, and the program outputs. You entered whatever you entered. Whatever you entered squared is X or whatever, and then your number cubed is blank. So just a basic program still. But that's it. We're done with lecture 4, participation in challenges. So that was what's due tomorrow night. So we're a little ahead of schedule. We've got about 2 more sessions today. So another almost hour of progress to be made today. So that's it for today. or not for today, but for now, I'll talk to you later today. See ya. All right, guys, I'm back for more CS. Let's just go ahead and jump right back into what we were doing before, which was an MSP. I'll be back at the end of the day to recall what I learned today. All right, so we finished up that MSP. Not much to note there. We started the next lecture, lecture 5, which is about arithmetic. And so, what is 5.1 about? Arithmetic operations. So essentially we learned an expression again. An expression is some combination of items or a single item that evaluates to a value. Evaluates to a value. A literal is an actual value, like the actual number or value written in code. So I think the string literal is also one. So I think it would just be one. So a literal is can be an expression. So that's really just one item, I believe, often. Maybe not. Maybe it wouldn't be a variable. String literal, float literal, floating number literal, integer literal. Then we've got what else? Gosh. The operator. An operator is a symbol that denotes some type of operation, such as the addition operator, which is the plus sign, subtraction operator, the minus sign. The minus sign can also be used as a negation operator, meaning turning something negative or opposite. The multiplication operator is a star sign. The exponent operation is a star sign, double star sign. I mean, it said it evaluates right to left, so I don't know which side. I would assume the left side is the base and the right side after the 2 stars is the exponent, but maybe it's the other way around, but I think it's probably left base, right exponent. And then the division operator is a forward slash. Okay. Right, and then order of operations, also known as precedence rules in computer science. Very, very similar to PEMDAS in typical math, except for negation comes before multiplication and division. So it's really PEN-MDAS. Throw that N between the E and the M. Expression letter operator, a symbol that performs a built-in calculation. Literal is a specific value in code. So, okay, an operator, that's a symbol that denotes a built-in or triggers a built-in, performs a built-in calculation, specific value in code. All right. So an assignment statement is not an expression. That was one of the example problems I worked on. I got that wrong essentially, or one of the practice problems. Right. When an expression evaluates, the value replaces the expression in memory. And programmers prefer to use parentheses, even if they don't need to, and they like to use parentheses in order to make it easier to read the calculation, the expression. Okay. We are done for right now. I'll be back later for 20 more minutes, and then that will wrap up week 2 of Computer Science 1. So see you for the final session this week in a little bit. All right, welcome back, everybody. The final Computer Science session for the week. This is a 25-minute session, and so when we're done, we will have just reached our 6-hour goal for the week. So Last session we were doing operators. We reviewed expressions, operators, literals, arithmetic operators. That's about it. I'm not going to go too deep because we just reviewed it a couple hours ago, and we'll recall it again tomorrow. Right, and then the, what do we call them? Something with a P, permeance, pervation, prevalence, preference, order, gosh dang it, precedence rules. That's the order of operations, essentially. All right, I'm gonna jump back into arithmetic operations. So I'll be back to recall in a little bit. All right, guys, I ended up spending most of the time on Canvas, just catching up on messages and updates and making sure everything's up to date on there. It was kind of boring. Most of it was irrelevant. I did learn that if you get below 75 on participation or challenge activities, you get an extended due date to make up work up to 75%. So that's kind of valuable information that I don't intend to get below 75 ever. Your first time being late, you can work up to 100%. So I don't ever intend to have that happen. So probably won't end up being of any value, but other than that, nothing else was really important. We started 5.2. We finished 5.1 activities. It was just work and participation. There was nothing to read. It was just participation and challenges. And then 5.2 we started, but literally read like one sentence. It's about Python expressions. We're starting with arithmetic expressions. One note was, so typically the programmers, they put parentheses to make reading the operation or the expression easier when it's not obvious, such as if it's like 5 times 3 plus 1, they'll put parentheses around the times, the multiplication expression, even though they don't have to, but it just makes reading it easier and makes it more explicit. The note was they do that unless it's the order doesn't matter, such as a bunch of addition, that's like, or a bunch of multiplication. Those are commutative laws of addition and multiplication. They're not going to put parentheses around the first multiplication and not the second, because the order doesn't matter. Even though technically the first multiplication is done before the second multiplication, because it's read from left to right, they're not going to put the parentheses there. It would actually probably make it reading it. It would make, they just don't do it. All right. So there we go. This is how I track my time. This is what I did last semester. So week 1, we did 7 hours and 40 minutes. This is week 2 though. The goal is 6 hours per week. So we did way more than necessary on week 1, but that's because day 1 was 2.5 hours of work doing all that intro stuff. So week 2, we're ending up with 6 hours and 5 minutes. So there we go. Another week. Check it off the list. Goal completed. Crazy how it's already going to be week 3 starting tomorrow. It's going to go fast. I mean, considering school is less than 20 weeks, we are already over 10% of the way done. Yeah, it will be over pretty quickly, considering I don't even know. I've been doing Make It Stick for 93 or 4 days now in a row, essentially, maybe 95. I think there's one day I didn't do it. I took a day off, just did like a 30-second recall. And that's almost a semester's length. Yeah, I don't think a semester is much more than 120 days, 4 months, so it will go fast. Anyway, that's it for week 2. Talk to you tomorrow. See you.